the acceleration during the first 4 seconds of motion modelled by the distance time graph below is 5 meters per second squared. Find v, find the total distance travelled in the first 12 seconds of motion, and find the displacement after 12 seconds. So in order to find v, we have to use the gradient of the graph here. The gradient of the graph here represents acceleration, and acceleration is velocity divided by time. So that will be v divided by 4, and therefore v will be equal to at. Therefore v is just going to be 5 times 4. The acceleration is 5 and the time is 4, which gives 20 meters per second. Right, having done that, we can now find the displacement. So what we're going to do is split the graph into 2 parts. This is above the axis, this area here is below the axis. The area underneath the graph gives distance. So finding that shaded area first, which is a trapezium. So now that's 20, we know this one down here is minus 20. So using area, we're going to say that S1 is going to be 10 plus 4 times the height of the graph, which is 20, divided by 2, and that gives you 140 meters. Now finding this one here separately, that's going to be this area here, which we're going to call S2. S2 will be it's a triangle, half times 2 times the height, which is minus 20, which gives minus 20 meters. But when we talk about distance, we just ignore the minus sign. Therefore, the total distance is equal to 140 plus 20, which is equal to 160 meters. Now, when it comes to finding displacement, though, we have to take the area of this one and add it to the area of this one, including the sign. So what we're doing, we find the area of this one, and we take away the area of that one. So we've got S1 is 140, S2 is minus 20. The total displacement, so displacement is distance in a certain direction, it will be S1 plus S2, which is equal to 140 plus minus 20, which is going to be 120. So it's a sort of a motion where it goes forward and then starts going back on itself. So therefore the displacement will be slightly less than the total distance travelled. If it's gone forward and then back, that's the total distance. If it's gone forward and then back, this will be the displacement. Okay, I hope you've understood. This has been a video to show you how to find distance and displacement from a velocity time graph. I hope you've understood, and I thank you very much for watching.